In the vast, silent theater of the cosmos, a drama of unimaginable scale might be set to unfold. For over a century, we've known that our galaxy, the Milky Way, is not alone. Hurtling towards us at over 110 kilometers per second is our largest galactic neighbor, Andromeda. For decades, astronomers considered a collision a near certainty, predicting that in roughly 4.5 billion years, Andromeda would plow headlong into our own Milky Way. This cosmic collision has been a staple of astronomical fascination, a future spectacle of stellar fireworks and gravitational chaos. But what if I told you the story has changed? Recent studies have thrown a wrench in those predictions, suggesting the collision is far less certain than we thought. And even more bizarre is what we've found staring into the very heart of our galactic neighbor. Andromeda isn't just a galaxy, it's a predator, and it's hiding a terrifying secret from its violent past, a second heart. This revelation changes everything we thought we knew about our galactic dance partner, transforming it from a familiar neighbor into a much more formidable and mysterious force. The impending encounter isn't just a potential merger. It's a meeting with a seasoned cannibal, and the evidence is written in the stars at its very core, the normal heart of a galaxy. So, to understand why Andromeda's secret is so profoundly shocking, we first need to get a grip on what a normal galaxy looks like at its center. Nearly every large galaxy, including our own Milky Way, has a single central point of immense gravitational power, its nucleus. And at the heart of this nucleus lurks a supermassive black hole, a gravitational monster millions or even billions of times the mass of our Sun. You can think of the nucleus as the galaxy's command center. It's the gravitational anchor around which hundreds of billions of stars orchestrate their silent orbital ballet. The stars closest to the center move the fastest, caught in a dizzying swarm around the black hole. This region is dense, it is powerful, and it is singular. For decades, astronomers assumed this basic structure was universal. A galaxy, we thought, has one heart. But when the Hubble Space Telescope turned its gaze to the core of Andromeda, it found something that defied this fundamental rule: the bombshell discovery, a tale of two hearts. In 1991, astronomers using Hubble to get the sharpest ever view of Andromeda's core were met with a stunning surprise. Instead of one central cluster of stars, they saw two. The galaxy had a double nucleus. These two distinct concentrations of light, separated by a mere 5 light-years, were designated P1 and P2 right away. This discovery presented a profound puzzle. At first glance, the brighter of the 2 points, P1, seemed to be the galaxy's center. But further analysis revealed something bizarre. The true center of the galaxy, the point around which everything was actually orbiting, was the dimmer peak. P2 is where Andromeda's supermassive black hole, a behemoth weighing in at around 100 million times the mass of our Sun, resides. So what in the world was P1? Why was this brilliant cluster of stars, offset from the true galactic center, appearing as a second, phantom heart? Several theories were floated. One idea was that a thick band of cosmic dust was just creating the illusion of two hearts. But that didn't hold up. Another theory is that the two hearts are actually an illusion created by a single eccentric disk of stars orbiting the black hole, making it look like there are two bright spots. But a third, more terrifying explanation remains a strong contender. P1 wasn't just a star cluster, it was a fossil. It was the surviving core of another, smaller galaxy that Andromeda consumed long ago. The double nucleus isn't a feature Andromeda was born with. It's a battle scar. It's the still-beating heart of its last victim. The ghost of a murdered galaxy. The theory that Andromeda is a galactic cannibal is backed up by more than just its strange core. As astronomers looked deeper into the space surrounding Andromeda, they found more clues to its violent history. They discovered the giant stellar stream, a vast, ghostly river of stars arcing through Andromeda's halo. This stream is the stretched-out, shredded remains of a galaxy that was torn apart by Andromeda's gravity billions of years ago. Think of it like cosmic crime scene investigation. The double nucleus is a potential smoking gun, and the giant stellar stream is the body outline chalked on the pavement. These features tell a story of a major merger event, a collision so intense it triggered a massive burst of star formation throughout Andromeda about 2 billion years ago. Andromeda isn't just a passive spiral galaxy minding its own business. It's a predator, built from the bones of its conquests. Its halo is populated by the stolen stars of its victims, and its core might just hold the undigested heart of another galaxy. This galaxy isn't just coming for us. It's coming from a long history of destruction. We are able to piece together these incredible cosmic stories thanks to decades of painstaking work by astronomers and institutions like NASA and the European Space Agency projects, like the Panchromatic Hubble Andromeda Treasury, or PHAT, have spent years mapping hundreds of millions of individual stars in our neighbor, giving us this unprecedented insight. If you find this journey into the cosmic unknown as fascinating as we do, remember to like this video and subscribe for more deep dives into the universe's greatest mysteries, a new vision of a cosmic collision. Knowing this history fundamentally changes how we view the potential collision between our two galaxies. This isn't necessarily a merger of equals. Andromeda contains around 1 trillion stars, and while its total mass, including dark matter, is now thought to be similar to the Milky Way's, its supermassive black hole is about 25 to 35 times more massive than ours. It is the undisputed heavyweight of our local group of galaxies. What was once thought to be a certain head-on collision in 4.5 billion years is now much more ambiguous. Recent simulations, incorporating more precise data, suggest there's only about a 50-50 chance of a merger within the next 10 billion years. It might be a sideswipe, a near miss, or a much, much later event. But if they do merge, it will be a spectacle. For millions of years, the two galaxies will dance a gravitational tango, distorting one another and pulling long streamers of stars and gas into intergalactic space. Our night sky would be filled with light and color as vast clouds of gas are compressed, triggering the birth of billions of new stars. Eventually, over hundreds of millions of years, the two spiral galaxies would coalesce. Their supermassive black holes would spiral towards each other, finally merging in a cataclysmic event that sends gravitational waves shuddering across the cosmos. The beautiful spiral arms of both galaxies will be destroyed, their structures scrambled into a new, single, gigantic elliptical galaxy, which some astronomers have nicknamed Milky. While the structure of our home galaxy would be gone forever, its stars, including our solar system, would likely survive, thrown into a new orbit within this new galactic metropolis. But here's the final twist. No human will ever see it. Long before any galactic merger, our own sun will make Earth uninhabitable. In about 1 billion years, the sun's increasing luminosity will cause our oceans to boil away, ending life as we know it. So, Andromeda's double nucleus is more than just a cosmic curiosity. It's a brutal reminder of the universe's true nature. It's a dynamic, evolving, and often violent arena where galaxies themselves are born from the remnants of others. The galaxy heading our way is a predator, defined by a history of cosmic consumption. We might be its next meal. But in that act of destruction, a new, grander creation could emerge. It is a terrifying yet awe-inspiring destiny. The two hearts of Andromeda remind us that even on the grandest of scales, the universe is filled with secrets, and the greatest events in cosmic history are still waiting to be written.